ProLearnix. Today, we're going to peel back the layers on some everyday numbers and find the really cool patterns hiding inside. We're talking about squares and cubes, and trust me, by the end of this, you'll be spotting their secrets from a mile away. All right, let's jump right in with a little challenge. Just take a quick look at these three numbers. Now, two of them are perfect squares, but one is an imposter. Any idea which one it is? Just go with your first instinct. If you picked 2032, you nailed it. And the really cool thing is, there's a super simple trick to know that instantly. No calculator needed. The entire secret is hiding in plain sight, right there in the very last digit. Okay, so let's get into this. This first clue is an absolute game changer for spotting perfect squares in the wild. So first, just a super quick refresher so we're all on the same page. A perfect square is just what you get when you multiply a whole number by itself. You know, like 4 times 4 is 16, so 16 is a perfect square. 10 times 10, that's 100, so 100 is 1 too. Simple enough, right? And here it is, the rule we use for that first puzzle. If you square any whole number, the answer is always going to end in one of these digits. 0, 1, 4, 5, 6, or 9. What that means is, if you ever see a number that ends in a 2, a 3, a 7, or an 8, you know right away it's disqualified. No way it can be a perfect square. But you might be asking, what if a number does end in one of the right digits, like 1089 from our quiz? How can we be sure then? Well, for that, we need to bring out a more powerful tool and break the number down into its most basic parts. So here's the crucial point. Every single perfect square is built from pairs of prime factors. You can think of them like little building blocks that absolutely have to have a partner. If even one of those prime factors is left all by itself, then the number just isn't a perfect square. Now check out how we can use this rule to solve something. Let's say we want to find the smallest square number that's divisible by 4, 9, and 10. First, we find the smallest number they all go into, the least common multiple, which is 180. Then we break 180 down into its prime building blocks. And what do we find? We get a pair of 2s, a pair of 3s, and a single lonely 5. That one little 5 is what's stopping 180 from being a square. So to fix it, we just give it a partner. We multiply by 5, and we get our perfect square, 900. Let's really put this to work now with a bit of a tougher example. See, we're moving beyond just identifying squares. We're actually going to build one ourselves. Okay, take a number like 9408. Doesn't really look like a square, does it? So let's break it down. We find it has 6 2s, 1 3, and 2 7s. Now the 2s have partners, the 7s have partners, but look at that one lonely 3. That's our culprit. That's the missing piece of the puzzle. To make 9408 a perfect square, all we have to do is give that 3 a partner. And so we multiply 948 by 3. That gives us 28,224. Now, all of its prime factors are paired up perfectly. And if you take the square root, what do you get? A nice, clean whole number, 168. See? It's just like solving a puzzle by finding that one missing piece. So, now that we've got a really good handle on squares, let's go ahead and add a whole new dimension to this. It's time to meet their three-dimensional cousins, the perfect cubes. The idea is pretty much the same. A perfect cube is just a number multiplied by itself 3 times. But here's the twist. Remember our building blocks? Well, instead of coming in pairs, for a perfect cube, they have to come in triplets, in groups of 3. All right, time for a quick pop quiz. You might hear someone say this: the cube of any odd number is even. So, is that true or is it false? Have a quick think. If you said false, you are 100% correct. It's actually a pretty common mistake to make, but when you look at the pattern, it's really clear. And here's why. An odd number times another odd number always gives you an odd number. So when you do that a third time, the final answer just has to be odd. The cube of any odd number is always odd. There are absolutely no exceptions. Okay, now that we're armed with the rules for cubes, let's use that knowledge to crack another number puzzle. Hey, this looks familiar, doesn't it? Let's take 1323 and try to make it a perfect cube. We break it down into its prime factors, and what do we find? We've got a complete triplet of 3s, that's great. But we only have 2 7s. To complete the set, those 7s just need one more partner. So we multiply by 7, and we get the perfect cube 9261. And here is an amazing trick that's just for cubes. The last digit of a perfect cube gives you this huge clue about the last digit of its root. Just look at the table. If a big cube number ends in an 8, you know for sure its cube root has to end in a 2. If it ends in a 7, the root has to end in a 3. It is such a handy little shortcut. So let's just put it all together for a second. Looking at them side by side really makes the main differences pop. With squares, remember, some ending digits are totally off limits, and their factors need partners. With cubes, any ending digit is fine, but their factors need to be in little groups of 3. So after all these rules and tricks, what's the big takeaway here? I mean, why does any of this really matter? Well, it's about something more than just getting the right answer. It's because when you start to understand the rules, you realize math isn't just about calculating things. It's about discovering these beautiful, sometimes surprising connections. I mean, just look at this pattern on the screen. It almost feels like magic, right? But it's built on the exact same principles we've been talking about, the same logic that tells us why a number can or can't be a perfect square. Learning these rules is like getting the keys to unlock these kinds of secrets. It shows us there's always a deeper pattern, always another connection, and always another puzzle just waiting for us to find it. So the only real question left is, what are you going to discover next?